Today, we're going to be talking about compound events. Compound events means that two things are happening at once. So our example could be flip a coin while rolling dice. Or you maybe pick a card as you flip a coin. Two things or three things or four things that are all happening at the same time. And we're eventually going to work up to the probability of those things happening at the same time. So like heads and you roll a 2. Stuff like that. So we're going to start with some new stuff today. The first thing I want you to write down is the definition of sample space. Sample space is pretty much just a list of all possible outcomes. So that means anything that can happen, we write it down. The fundamental counting principle is used to find the number of possible outcomes, of total possible outcomes. So there you are. So we're given this chart. Whereas, if you read your description, it says the number of options from dice, so we rolled a dice, and if we flipped a quarter, so heads or tails. We're going to find the compound events that happened. So our options are heads 1, tails 1, heads 2, tails 2, heads 3, tails 3, heads 4, tails 4, heads 5, tails 5, and head 6, and tail 6. So our question is, what is the total number of outcomes? So we learn from our fundamental counting principle that we take the number of times something could happen for one thing, the number of times something could happen for another thing, and we multiply them together. So we ask ourselves, how many different options are there for a quarter? Heads and tails, so 2 options. How many different options are there on a die or dice? 6 different options for that. So it's the amount of time something can happen for one, and the amount of time something can happen for the other, and we multiply them together. So 2 times 6 is the total possible outcomes. So 2 comes from the quarter, the 6 comes from the dice. And if we count, we actually get 12. We get 12 different options. So we take the number on one and the number on the other. So we're given the same chart as we were working with last time. Now we're trying to find probability. So our probability is what's the probability of rolling a number greater than 4 and tails. So if you look at your paper, you'll see the number of favorable events over the number of possible outcomes. Or the number of time we got tails and we rolled a number greater than 4. Greater than 4 means it's not 4. Okay, so let's just look at our chart and find out. Do we have any numbers greater than 4? Yep. That are tails. So there's only 2. There's 2 options. Because we got tails and got a 5 and tails and got a 6. So we had 2 options that we could have gotten over our total possible outcomes. So if you remember, our total possible outcomes was 12. Reduce. So our probability tells us that for every 6 rolls, we'll get one number that's greater than 4, and we flipped tails. So let's look at another example. Let's say you're on a game show with 3 different colored doors. So the first door is red. The next door is blue. And the door after that is orange. Now, each door has a chance of opening. And each door has a chance of being either a prize or no prize. So we're going to check out the probability of what would happen if you opened all 3 doors. We're just trying to find if you can get one prize. You want to go home with one prize. So I made a chart on there, and I just need you to follow along. So we had the first red door. Let's say it had a prize in it. And then now the blue door had a prize in it. And now the orange door had a prize in it. Or the red door had a prize in it. Or the blue door had a prize in it. But the orange door did not have a prize in it. Red door had a prize. Blue door did not. But orange door did. Blue door did. Red door did. Blue door did not. And orange door did not. Next, we'll go down here. We're going to say the red door did not have a prize on it. But the blue door did. And the orange door did. Now, the red door did not. And the blue door did not. But the orange door did. I think we skipped one here. We'll go back to it. The red door did not. The blue door did, but the orange door did not. Now for the last one. The red door did not, the blue door did not, and the orange door did not. So our first question we have to ask ourselves is, how many different outcomes are there? So if we looked, we could go prize, 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 no prize, 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 no prize, prize, and then prize, no prize, no prize. Now we go back down to our one I read was no prize, 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 no prize, prize, no prize, no prize, no prize, prize, and for the last one, no prize, and no prize. You go home empty-handed. So how many total possible outcomes are there? Well, that's easy. The red door had prize or no prize. So there's 2. Times blue door had prize or no prize. That's just 2. Orange door had prize or no prize. So prize or no prize. Just 2. 2 times 2 times 2. That's now 8. So there are 8 total different outcomes that we can get. But if you just wanted to, you could count them. 1, 2, 3, 4, 5, 6, 7, 8. So now, of course, what's the probability of getting at least one prize? So we count any number or anything that has a P in it. So 1, 2, 3, 4, 5, 6, 7, and that's it. This last one does not have a P in it. So we look at our probability of the event. Our favorable outcomes are what we're looking for. So we said what we're looking for is we want to go home with one prize. And 7 of our options, we went home with a prize. Now, how many total outcomes were there? We just saw it. 8 different outcomes. So we went to our game show. Let's start with that. We went to our game show. We opened 3 different doors. So blue, either won or lost. Now, so red, you won or lost. Blue, you won or lost. Orange, you won or lost. And you go down by these different categories. We found our total possible outcomes because our blue door had 2 options, our red door had 2 options, and our orange door had 2 options. So we got a total number of 8. The probability of our event, if you look at your paper, we're looking for our favorable outcome. So, favorable outcome are what we want to happen, or what we're looking for. So we're looking for how many prizes, for at least we won 1 prize. Every one of these, except this one, won a prize. So 7 of them won a prize. Out of the total number of trials. 8. So you had a 7 out of 8 chance of going home with a prize on the game show. So let's look at a taco truck. This will be a good example to show all the sample space, or all the things that can happen. So, we have 2 breads provided by our taco truck, if you read your paper. We have 4 meats that are provided by our taco truck, if you read your paper. Now, we're trying to figure out how many different outcomes there are. So let's say we had wheat bread, and we had sourdough bread. So our different kinds of meats are ham, turkey, steak, and of course, then chicken. So this wheat can be a ham on wheat, a turkey on wheat, a steak on wheat, and a chicken on wheat. You could also have ham on sourdough, turkey on sourdough, steak on sourdough, or chicken on sourdough. So let's count our options. We have ham on wheat. We have turkey on wheat, steak on wheat, chicken on wheat. Then we reset down to ham on sourdough, turkey on sourdough, steak on sourdough, and then chicken on sourdough. So we have all these different options, but let's count them. 1, 2, 3, 4, 5, 6, 7, 8 different options that we can have. So this would be our sample space, or a list of all our different outcomes. And it turns out we have 8 different outcomes from looking at our sample space.